Let's move on to our last alcohol synthetic reaction, and that is hydration. And what we're looking at here is starting with an alkene and going to an OH compound. And let's look at the mechanism for that. Now, looking at the reaction, you've got H2O and H+, and you'll notice there's no numbers here. And those numbers, of course, the absence of numbers obviously means that we don't have to necessarily start with the H2O. And usually what we notice is that if we've got a choice of two things to start with, always start with the thing that's charged, because that's usually going to be the most reactive species of the two. So if we've got H2O and H+, and we're going to react it with a double bond. We saw this reaction a bit earlier in the mechanism explanation, but what we're doing is we're going to take two electrons out of this CC double bond, and we're going to form a new CH bond right here. Now there's the new CH bond, and that's going to leave a positive charge down here. The reason for that is because we have used two electrons from this CC bond to form a new bond between this C and this H. Effectively, we have taken one of the electrons that belonged to the C in this bond, has now been used to form a new bond with this CH. Now remember, there were two electrons in here, one belonged to this C, one belonged to this C. Now both electrons from that bond are forming a bond with this C and this H. So this C isn't losing any electrons, but this one is, so that gets a positive charge. Now in the next step, we're going to have water. Now water, as you know, is going to be electronegative on the oxygen, so it's going to be a delta minus, and you know that oxygen has two lone pairs on the O. So it's those lone pairs that can now react with the positive charge, and they'll be attracted to the positive charge because these are negative and the positive charge is positive. So the O is going to form a new bond with the C that had the positive charge on it. In so doing, though, we're using two electrons off the oxygen, and only one of those, now one of those is going to be here, and the other one is going to belong to the C that had the positive charge. So now the oxygen has actually given up an electron to satisfy this C. That leaves a positive charge on the O. The other reason we know this is positive is because now the oxygen has three bonds on it, and usually when oxygen has three bonds it's going to be positively charged. The last step here is that the O plus will lose a hydrogen. Now the way we express the arrow is like this, and what we're trying to say there is that the OH bond is breaking, and the electrons, both electrons from that bond, are going on to the oxygen, and now that oxygen will have a satisfied charge because it's taking the electron away from the hydrogen to satisfy this positive charge. Remember, there's two electrons in this bond, one belongs to the H, one belongs to the O. They're both going to belong to the O, and that's going to get rid of the positive charge and end up putting it on the hydrogen. Right, let's just show that last step. And that leaves an H plus, and that's that hydrogen right there. It becomes an H plus, and it becomes an H plus because it lost its electron. Now, a common mistake that people make with this mechanism is instead of showing an arrow that goes towards the oxygen, they decide to do something like this. And I know what they're trying to do. They're trying to say that this hydrogen is going to leave, but that's not the right way of saying it, because these arrows show electron movement. They don't show the movement of atoms. Now what this arrow wants to show are the electrons going on to the oxygen and breaking the bond that way, not breaking this way and then leaving something silly happening here. So that is not the way to go about it. And again, this is all a consequence of the fact that arrows show the movement of electrons.